Welcome to Chem 12 101, where I'll be teaching you about reaction rates. But first, I'm going to need a beat. Let's start with collision theory. What exactly is it? Before I tell you what it is, I'm going to tell you what it's not. Collision theory is not Godzilla eating a bus full of kids, or Baby Yoda's first name. It's also not this butterfly. Now, what exactly is collision theory? It's the theory that chemical reactions can occur only if reactants collide with proper orientation and with enough kinetic energy to break the reactant bonds and form product bonds. Let's look at an example of a collision that results with the reaction occurring. Let's look at one more example. Now let's look at an example of a collision where the reaction does not occur. Whoa, collision theory is pretty whack. But now we're going to get into another topic, activation energy. This is the minimum energy that reactant molecules must possess for a reaction to be successful. Picture yourself at the bottom of a hill eating Cheetos, but you pulled one out and it's just way too big to be eaten. So you've got to put it back in the bag, but the bag is all the way on the other side of that hill. You've got to find a way to get the Cheeto back in the bag, but if you roll it halfway up the hill, it's going to roll back down and crush you. You've got to roll it all the way up the hill for it to reach the bag. The top of the hill represents activation energy. It has to be reached in order for a reaction to occur. Now let's talk about temperature, which is defined as the measure of the average kinetic energy of a substance. If the average kinetic energy of a substance is increased, then that means the probability of effective collisions is more likely. In fact, an increase of about 10 degrees Celsius will often double or triple reaction rates. The chemical nature of reactants is also a key factor in determining reaction rate. Reactions involving breaking fewer bonds happen faster than the breaking of larger number of bonds. It also takes less energy to break a single bond than a double bond, and size and shape can also affect how they collide. Concentration and surface area. Increased concentration means a higher likelihood of entities colliding, and increasing surface area increases the rate of reaction because more entities have access to each other in states such as gas and liquid compared to solid. Now let's talk about catalysts. Catalysts are a substance that increases the rate of a reaction without undergoing a permanent change. A catalyst provides an alternative pathway for the reaction that has a lower activation energy. When examining this graph, you can see that the catalyzed reaction has a significantly lower activation energy than the uncatalyzed reaction. Now that you know about reaction rates, let's recap what we learned today. We talked about collision theory and why collision geometry is very important for reactions to occur. Some orientations will work while others will not. We talked about activation energy, which is the minimum energy that reactant molecules must possess for a reaction to be successful. We talked about temperature and why increasing it causes the average kinetic energy of some entities to increase, which means that the probability of effective collisions is more likely. We also talked about the chemical nature of reactants and why their properties can also determine the rate of reaction. We also talked about concentration and surface area, and why increasing concentration and increasing surface area results in a higher rate of reaction. And finally, we talked about catalysts, which provide an alternative pathway for the reaction that has a lower activation energy. This has been Chem 12 101's lesson on reaction rates.